Um, I welcome you all to this tutorial series on Apache Spark Big Data Architecture. So let me briefly talk about what we are going to learn in this, and accordingly you can go through these lectures or videos. So basically we will be covering about big data ecosystem and in Apache Spark, how it is used, what are its benefits and all, and how it optimizes any big data process. And we will be coding along. We'll see lots of examples and we will code along. We will be using primarily we will be using Scala. However, I would be covering the PySpark examples also, as many data engineers are using Python for the analysis. So the core concepts and theoretical concepts I would be talking about while writing the code in Scala. But then if you are coding in Python, you can just go through it as a theoretical concept. You don't need to code it in. And then in the next couple of lectures we will be talking about the same implementation in the Python. Most of the functionality is going to be the same, only some syntax things like the anonymous functions in Python would be lambda, and then tuples, etc. Those are the things that would vary a little bit, but we will discuss as we go along. Okay, so yeah, this is an overview of this course. So we will be understanding big data architecture. We will be first learning the core concepts and live examples. We will get ourselves familiarized with all these concepts, and once we get a good grasp of all these concepts, we will be going through a lot of theory as well. So to understand exactly how things are working, it's very important. And then we will have practical examples to demonstrate the utility or advantage, and that would be the flow. So yeah, I mean, at times I might be discussing something which you already know, like the concept of reduce, map reduce in big data, that you might be familiar with. So if you find something that you already know and are well versed with, you can definitely skip that content and go to the next one. However, if you think that that is something you are not very good with or you don't know at all about it, then you can stick to it and go through it. Okay, so this is our first lecture. Here we will be talking about the architecture of the Apache Spark. So it basically, you can say it's an improvement of Hadoop, which came in, I guess, around 2006. And then because the limitation of processing the big data parallelly, now you can know that lots of data is generated every day. So we need faster computers. And even the processing can be extended to a certain limit, and that is why parallel processing is very important, distributed processing, you might say. So the main concept that Spark introduces is distributed processing, and we will discuss how it is. So yeah, I have made these notes. So this is my GitHub repository. I'll be pushing the codes and everything. So you can always look at it. Let me top 5-6 folders you can ignore totally. However, from assets, we have some assets for examples. Then chapters, here you will find all the notes. These are all MD markdown notes, so you can always go through these. Yeah, and then in the main you will find two folders. One is for Python and one is for Scala. So Scala you will have like these, and for Python I am initially I was thinking of using normal .py files. However, I found that Python notebook would be much more intuitive. So now I would be using Python notebook, and you will see all the examples of different chapters in there. Okay, and then virtual environment, because yeah, you may want to have a virtual environment. All the packages that I would be using is listed in requirements.txt, and all the sbt Scala packages is in build.sbt. Okay, so yeah, I mean, you can always refer to these notes. I would be sharing the link of the particular related to particular chapter in that description. And I have multiple branches, so if I do git branch, you will see different branches for different chapters, and you can go through those to understand the concepts and everything. Okay, yeah, so that is an overview. So let's get started. So this basic, I'll go through the notes and then I'll show you the demonstration. This is anyways going to be theoretical understanding, so here there is no practical coding example. but this is about the Spark architecture. Okay, so we will talk about Spark architecture. If you are well versed with it, you can skip this video and move to the chapter 1 where we discuss a little bit about installation and all. If you are new to this, then you can go wait and watch this all to understand it properly. So it's built on the concept of distributed computing, allowing it to handle big data by dividing the workloads across a cluster of machines. Okay, so there's this cluster which is responsible for providing the necessary machines which could trigger um, these actions, and this whole architecture is distributed into these three key components. One is driver program, which you can consider as supervisor of all these things, so which takes care of everything. Then we have workers, which executes the program on instruction from driver. And finally we have cluster manager, which basically is helpful in which communicates with driver and assigns the required machines to workers to perform the task. Okay, so the driver is the central coordinator of Spark application. It's where the main logic of application is defined and it runs on the master node. Okay, and this is responsible for scheduling tasks. So these tasks can be given by the user. You can schedule multiple tasks in Spark, and this basically how the schedule is going to work, when it is going to trigger, when it is going to track the progress. All these things is managed by driver. This also can be called as maintaining information, and then collecting the results, like how the task went, what is the result, and then return it, perform side effect, whatever that is there. And managing shared variables. So this is one of the very important concepts, broadcast variables and accumulators. We will have a separate lecture on it, so I'm not talking much about it, but in short, it helps you to manage the variable life cycle across different clusters, if you want to cache something or if you want to reuse something. So it talks about that. Okay, and Spark uses RDDs, which is resilient distributed database. So basically this is the core of the Spark, which helps it for distributed computing and allows it to follow parallelism paradigm, which is very helpful in computing at a high speed. Okay, the driver converts high level Spark operations like transformations on RDDs, which is resilient distributed data sets, or data frames, which is built on top of RDDs only. However, it offers more optimizations in terms of catalyst optimization and couple of other concepts that we will be discussing. Into a directed acyclic graphs, meaning that it cannot go back, it's direction with direction. And then broken down into tasks. Okay, workers executing tasks are machines in cluster that perform actual computations assigned by the driver. Each worker runs executors, which are processes responsible for executing tasks, storing data, reporting task status back to the driver. Okay, and the cluster manager allocates resources across the cluster. The cluster management, Spark supports various types of cluster managers, which is standalone, Apache Hadoop Yarn, which is yet another resource manager, and Apache Mesos and Kubernetes. Okay, the cluster's job is to provide worker nodes to run Spark executor, making sure that enough CPU memory and resources of for tasks to execute. Okay, so this is the high level overview of the entire Spark architecture, and here is a diagram. So we have a driver, we also have the cluster manager, which is in sync with driver and helps to assign these workers with proper cluster and infra. Okay, so word count application is one of the very popular applications in understanding not just Apache Spark, but lot of concepts of map reduce, how distributed computing parallelism works and all. And we also have discussed this. We will be discussing this in upcoming lectures, how it allows you to perform parallelism and perform these operations in parallel. So as the user writes a Spark application in Scala, Python or Java, we will be most focusing on Scala and Python. The driver starts to run on the master node. It reads the text file and defines a series of transformations to apply to the data. Example is splitting the text into spaces, words, basically splitting by spaces, and then mapping each word to count of 1, which is initial count for that word, and then combining them. The driver divides the input data into small chunks called partitions. Each partition will be processed in parallel on different workers. The driver converts the high level operation, which is like map or reduce by key, into directed acyclic graphs of tasks that can be executed in stages. These stages are divided into tasks and sent to the worker nodes. Okay, So I mean, you are getting this concept, right? Basically, so all the tasks, once, like, let's say there is reduced by key or map, then all these tasks would be given to these workers and they would be individually running these tasks. And task core is like, these executor could be either having task and core operations, or only core or only task operations. In our case, we will have both of these, and then these would be instructed to perform that. And that's what we are talking about here. Okay, into the task and sent to the worker nodes. Now worker nodes receives one or more tasks from the driver based on the partitioning of data. For example, worker 1 might perform the first chunk of the text file. So let's say your text file is too big. Okay, so for example, if I go to, yeah, this is the text file. So these 3 lines are there, right? So each line can be partitioned, I mean, it could be partitioned based on the line, and then each line could go to, one worker, and then it could perform the task. Okay, worker 2 might perform the second chunk, and so on. When the worker is finished processing their chunks, they may need to shuffle the data. So let's say, where is that again? So let's say this is coming twice, right? So this count will be coming one from this particular line and one from this particular line. So we need to shuffle these together to give us proper output. And I guess we have discussed this in chapter 3 or chapter 3 reduce. Yeah, so this one here we have already discussed this in detail, so I'm not going to talk about it again, but you get the idea, right? So basically all these tasks would be given, and then once they are computed on individual, then these would be combined together or shuffled together to come up with the final output. The shuffled data is sent between workers over the network to group the words and their counts, and then after all tasks are complete, the final results are sent back to the driver. The driver can then aggregate these results or send them back to the user. Okay, so basically based on if it is supposed to be aggregated, then driver would aggregate it, otherwise it will send it back to the user where they can perform whatever operations they need to. Okay, and this is some word count code. We will be discussing this also in detail. Yeah, and again this example. So here is a very simple diagram. So driver submits the job, creates DAG schedules, sends the tasks to worker node executes the tasks, processes data shuffling if required. If these are not required to shuffle, then they will be returned directly, and then finally it completes. Okay, so Spark architecture consists the driver, workers, and cluster manager, enables efficient distributed processing over large data sets. The driver coordinates the computation while worker executes the task in parallel, and the cluster manager ensures optimal use of resources. This architecture allows Sparks to scale efficiently and perform well in big data environments. So I hope you got a gist of Apache Spark, how it is doing things and what are its core components. In upcoming lectures, we will be seeing examples and different things and all the theoretical concepts as well as the programming concepts as well. Yeah, so that's all for this video. In case if you have any questions, feel free to drop in the comments. If not, I hope you are liking the content. If you have any suggestions, feel free to drop them as well. Anything about the delivery or anything about the example or any other thing, feel free to add it out. Okay, that's all. Thank you very much.